video, we're going to be discussing 4 demos that I made to explore angles with different units and forms. So the first demo is in degrees, the second is in revolutions, third is in radians, and the fourth is a different form. There's 2 forms. So it's radians with multiples of pi, and then I also have it in terms of simplified fractions. So 19 and 3 are already simplified. However, this is the same thing as 76 pi over 12. So we'll talk about these demos in a little bit. So let's start with the degree demo. The point of this video is to just to discuss some of the functionality of the demo. In a later video, we can talk about how we can use this to kind of explore learning the angles. So this right here is I can move this to rotate around. What I see is if I rotate in a positive direction, I get a positive angle, which is blue. If I go in the negative direction, I get a red angle, it's a negative. It also wraps around so you can see how many times you've made any full number of rotations. This right here is the terminal side and point. If I turn this off, that line goes away. If I want to see the coordinates on the unit circle, I click this point here. I click the label and it turns the coordinates on. And that is the end for that. If I want to adjust the window, for instance, there are some cases where if I'm pointing down like that and I click label, it's kind of at the bottom and I kind of don't like that. I could zoom in around like this, or this is what I prefer to do. Grab this and then move it so that the unit circle fits kind of like in a nice smooth way. You can also manually go in here and change the X and Y coordinate axes. However, that can distort the picture. So I prefer just to move this. And also if you're doing full screen mode by clicking F11, that will also change the window that you're seeing. Okay, so let's turn the label off. The point of the video is just to explore the angles themselves. Okay, this is the angle in standard position. This is the number of rotations plus the angle, which is 1005 degrees. This is my coterminal angle, positive version. That's between 0 and 360. This is my coterminal angle that's negative between 0 and negative 360. This is my reference angle. Reference angle is always positive, and it's the angle to the nearest positive x-axis. So if I move this, you see that it moves like it has to. If I graph coterminal angle, the negative version, see that negative coterminal angle always has to be between 0 and negative 360. Okay, so this is the main functionality of the demo. There are some things I can play around with, including the number of full rotations. So let's go back up here again. This right here allows me to do negative 1,800. So that is, as a multiple of 360, that's negative 5. So I can do negative 5 rotations one way and positive 5 in the other. And that's the total number of rotations it'll allow me to do. If I want to do more rotations, then what I'm going to do is go down here and change the number of rotations. The max I'm allowing for 10 is I could always go in here and change this number. But if I just click this and I say, oh, I want 10 rotations now, what it does is it more tightly packs all the rotations into this little area over here. So now if I decide I'm going to go all 10 positive rotations, then that's 10 times 360. I could also do way more than that. I could do 100 rotations. But then now it just starts getting ridiculous. It is cool to do. I recommend doing it and then playing around with it. It's a lot of fun. Let's go back to 5 rotations. Another thing you can do with this is you can push play. It will animate how it's moving. By clicking this, you can change the style, how it moves around. So this right here will loop back and forth. So it'll rotate one way, all it can go, and then bounce backward and go back and forth. This right here repeats going forward over and over again. This only goes forward once. You can change the speed. You also can do other things. If you go down here, if you click here, you see that the step is D. Now, the D right here is determined by this. I chose that it would be 360 divided by 24. So 1/24 of a full rotation. And that corresponds exactly to these grid lines here. So if I click up here and I click axis numbers, there's the rectangular grid and there's the angular grid. If I use the axis numbers here, you see it's broken up into 360, 0, 30, 60, 90, etc. And within the main ones, there's also smaller angles. So this right here is 15, 45, and then, 75, halfway in between 60 and 90. If I wanted to exactly get this right here, where I exactly get these grid marks, then I just say, well, how many of these grid marks are there in a full rotation? Well, there's 1, 2, 3, 4, 5, 6. There are 6 in a first quadrant, and there are 4 quadrants, so it's 24. Another way to do that is you say, okay, to get to 90, I need 3 copies of 30, and then that means 6 because I can cut each of these into half. So it's 6 times 4 quadrants, so it's 24. However, I could also choose this to be, okay, over 3. So now all of my rotations are going to be multiples of a third of a rotation. So if I move this around, it's only going to 3 possible spots. It can go to 0, 1/3, 2/3, and it's only doing multiples of those. So it can start at 0 here, and then go to 1/3, which is 120, and only do multiples of 120, 240, 360, and then another multiple of 120, just adding 120s. So this right here, you can explore some of the properties when you move around on the unit circle. There are certain patterns and stuff that you can explore. You can also go in here and manually just write in something like, I don't know, 45, if I didn't want to actually think of it in terms of a fraction. Now this is 45, so all the angles here are going to be multiples of 45. 45 is an eighth. It's a half of a quarter of a rotation. So I can get all the axes and the points halfway in between, but that's about it. Okay, and so this is how a lot of the demos work. This is the one with degrees. There are some slight similarities and differences in the other ones. So the main differences are because you're using a different measure for the angle, or a different unit, or a different form, you will actually be able to see certain patterns. So if I go over here and I say, this right here is in terms of revolutions, which are also called rotations or cycles. So if I do, let's see, 2.083 revolutions. Well, the 2 integer part means how many full rotations, and then the 0.0833 is the reference angle. It's how much more I need to go from this part. And you see that's the same number as the decimal part here. However, if I go over here, that's not the same as the decimal part. But what you see here is that if you add these decimal parts, you get 0.5, because 0.5 is the angle right here that represents the negative part of the x-axis, because it's half of a rotation. And so you can explore these kinds of things as well. This m right here is just how many revolutions there are. This is slightly different. It's similar to the revolutions, actually. It's that it's in terms of decimals, but it's radians. So earlier, what we started with degrees, revolutions, and radians. And these are all different units, and radians are the only units that actually are not considered units. So 3.14159, it's the only unit for angles, at least. So this right here is pi, and it represents a half of a rotation. Now, if I go through and I change this, you see that I get different rotations. And the numbers are actually not too informative, but it does help you get some kind of idea about what a radian is. So what is 1 radian? 1 radian is about there, and it's about a third. Well, it is exactly 1/3 of a half of a turn. Let me search. I misspoke. Yeah, oops. So pi radians is that, and that's pi is about 3. So if I actually hit pi here, it's exactly, if I do pi over 3, that is a third, which is exactly this thing. The thing that I have 1.047, the thing that I had just a few seconds ago, this is exactly a third, but it's only because I'm going in certain steps. If I just chose exactly 1 radian, it wouldn't be a third anymore. It would be, where is it? 1 radian is slightly smaller than this. So it is slightly less than a third of a rotation, a third of a half of a rotation. And 6 full rotation, a full rotation you see here is a little more than 6. One thing that's annoying, which comes up with these sliders, is it's hard to exactly get certain angles sometimes. I was able to get it there, but I was having trouble doing it the first time. One thing you can do is you click here and then hit tab tab. Now I'm selecting the cursor and I can move left and right, and it gets me nicely on the spot that I want. So this is the angles with radians. If I do it in terms of radians, but in terms of fractions, there are two main ways of doing it. One way is kind of the nicer way in terms of being able to put all the angles down on your unit circle if you have a unit circle quiz, or if you just need to find out where an angle is. One thing you can do is, okay, let's start with like a simpler angle. 5 pi over 6. Okay, but quite honestly, when I see that, I don't know exactly where that is. I have to think about it. If I think of it in terms of full rotations, that's still not very helpful because 2 pi is a full rotation, and 5 pi over 6 is not kind of like a nice multiple of that. It is a nice multiple of pi. So pi is a half of a rotation, so it's 5/6 of a half of a rotation. So it's 5/6 of going all the way to the opposite side. So that kind of doesn't make sense. If I'm doing my unit circle quiz, quite honestly, what I like to do is to do everything in terms of multiples of 12. So that's why I have 12 here. And these are what the denominators are secretly. This demo right here actually started here, but I simplify all the fractions. So if I click here, this is it in terms of 1/12. So if I go over here and let's start at 0, and I'm going to click this, tap, tap. 0/12, 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, 8/12, 9/12, etc. These right here are going to include all of the special angles that you need to have memorized, and then a couple more. Now, the really neat thing about this is that if I go and turn on the simplified form, so let's start back at 0. This is 0 out of 12, 0 out of 1. It doesn't really matter. They're the same. 0. This is 1/12. This is 2/12, but 2/12 simplifies to 1/6. And then 3/12 simplifies to 1/4. 4/12 simplifies to 1/3. 5/12 doesn't simplify. 6/12 is a half. And then you can keep going. So what's really nice is that if you have no idea what an angle is, this is 76 pi over 12. Well, 76 pi over 12 is just 19 pi over 3. And that may or may not be helpful. But the thing is that sometimes when you're trying to understand where the angles go, it sometimes is nice to have the unsimplified form, because the simplified form involves fractions that are more annoying to deal with, or just you're not as familiar with them. By the time you're done dealing with these angles, you do a lot of examples, you will start to pick up the hang. You'll start to get the hang of where certain angles should be or not, and you can also reason your way to it. So that's something you would study more in a class. They do more examples and fool around with things. Again, you can also do things like coterminal angles in both forms. So if I have a coterminal angle, this is negative 20 pi over 12. If I wanted to change the denominator, I wanted to make the denominator out of, I don't know, 6. You got to be careful with the 0 here. Okay, so this is negative 11 pi over 6. I can do all of the multiples of pi over 6. So I'm going to go over here and change my step size to pi over, oh, this should be pi over n naught. Oops. Okay, so pi over n naught. This right here is my step size. And so if I go up here, I click, tap, tap, I'm moving by pi over 6s. So the unsimplified fraction form is going to have the denominator with pi over 6. But then I can see all of the different patterns that happen. Because when you have multiples of pi over 6, because pi over 6 is not a prime number, you end up getting multiples that simplify. So the first one you get is, let's see, tap, tap, 1, sorry, I wanted the, not the negative coterminal. I just wanted the normal angles. So I see here 1/6. 1/6 is a normal kind of angle. 1 out of anything, it's not going to simplify. 2/6 is going to become 1/3. So if I'm looking for the patterns here, I see 1/6, 1/3, 1/2, 2/3, 5/6, then no fraction, and then 7/6, and then 4/3. This is kind of really hard to keep track of where all the numbers are going. If I had a specific angle that I wanted to, I could put it down and then think my way to what the angle had to be. However, what I like to do sometimes is if I'm just counting by multiples of pi over 6, then I like that non-simplified form. 0 pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. And then I can just go by and then simplify all the fractions. But it's really easy to write down all the angles and actually just to graph them. Because once I know how much of a turn, based on this graph, it's 2 of those angle grid marks. You see that I'm going from here up by 2. That's 1 pi over 6. And then once I see that, I can actually plot out all the other points. I don't even need to think about it too much. This right here is going to be 2 pi over 6. This is 3 pi. This is 4 pi. This is 5 pi. This is 6 pi, 7 pi, 8 pi, 9 pi, 10 pi, 11 pi, 12 pi. Of course, 12 pi is 2 pi. And then what I can do is simplify all the fractions. So this right here is a nice demo, and all the demos together, I'm really excited about them. So feel free to let me know in the comments, or if you're taking one of my classes, feel free to let me know if you like it. I hope you have a nice day, and one thing you can do is explore how to deal with these and deal with these different types of angles. And what I would recommend is start with simple things. Start with the degrees, try to get an understanding of it. The last thing I need to mention is the mode. So if I click here, this is in degree mode because I'm doing the degrees one. However, the other ones are not in degree mode. This is in radian mode, and this is radian mode. So in particular, if I just throw something random down, and I say, what is the cosine of 3.9269908? That's this, negative 0.0707. And if you actually recognize this is negative root 2 over 2. Because this angle right here, if you think about it, is actually going to have a reference angle of 45 degrees. And this is because it's in radian mode. So this is radians. This is a radian angle, and the cosine is the x-coordinate. If I go over and look at the terminal side and I click show me the coordinates, that is the negative 0.71, 0.707. Now, if I go over to these other modes here, like revolutions, and I say, okay, this is 2.4166, I do sine of 2.41666666. It's telling me that the sine is 0.6. If I go and look at the coordinate, the sine is 0.5. Because this right here is a 30-degree angle. And the sine of 30 degrees is a half. However, this sine right here is not the sine of the actual angle, even though that's what it looks like the angle is. The reason is about the units. This is revolutions, and it's not radians. This is more important for the angles with degrees, because if I just write in, I don't know, cosine of 1800, oh, that's nice, because it's degrees. These are both, these are both in degrees mode, degrees here. That's why the angles here are degrees. If I go over here and I click graph the axis numbers, it's going to give me radians in terms of pi's. However, I don't actually want that. That's one reason why these axis numbers aren't here, because revolutions are different. So I just want to say that this right here is in radians, this is in radians, however, this one's in degrees. Like I said, feel free to let me know if you have any questions, and I'm interested in hearing whether or not this helps you kind of explore how to understand angles. And it's really important that, especially if you're doing your homework, to not use a tool like this to just fly through all the homework and not learn anything. This is really just for you to help explore when you're trying to draw it on your own and trying to understand what an angle is and how much is 900 degrees or something. If you can find a way that helps you internalize what you should be doing, like, okay, if I need to sit down and learn what 900 degrees are, I'm going to go down here and click the step tab, and then go back to 0. And then I'm going to try on my own piece of paper to write out what 900 degrees is. I'm going to try to find out how many full rotations there are, and then try to find the remainder. So if I go over and I say, I'm counting, I'm going to 900, and that's 900. What I could have done, what I couldn't do now is say 900, and so that was 180. Well, how do I get the actual not integer part? The not multiple part. That's the 180. Well, I do 900 and minus 180. 180. That is 720. So what I see here is 720 is a multiple of 360, and that is smaller than 900. So this is kind of the remainder, like if you were to do long division. If I were to do 900 divided by 720, there would be a remainder of 120. Or if I did division by 360 either. So there's certain things like here that you can do, and things that we will be doing in class if you're in one of my classes. And what you will do is that you will be doing a lot of the calculations, and you will try to draw some things, but it's important to not be reliant on graphs like this, because they're really helpful, but it's important to actually be able to internalize the ideas so that when I give you an angle like 900 degrees, you can actually go through the calculations. You know that you're supposed to be looking for a multiple of 360, and then you're supposed to subtract multiples of 360 until you get a number less than 360. And that right there is going to be your coterminal angle between 0 and 360. Certain things like that. If you go through those calculations, having it visually is nice to reinforce those ideas, especially when you're learning to just put things on a graph, trying to decompose into coterminal angles, their reference angles, what are all these different things? These help you check your work, help you understand what you're doing, but it's important to not just rely on it. Do not take your homework and say, okay, I need to graph, let's see, I need to graph 19 pi over 6, so I'm going to go over here and change the denominator here to 6, and then move my thing up here to 19, and I get 19 pi over 6. 19 pi over 6 is right there. And then I say, okay, what is the sine and cosine? Well, I can go over here and click the terminal. The cosine is this ugly number, and the sine is this ugly number, and then I'm going to recognize that this one is negative root 3 over 2, or whatever. There are different things you can do. I can say, oh, this is in my third quadrant. There are certain things that you can do just by looking at the picture, which requires you to do no thinking at all. Do not do that. The important thing is that this is to help support you. It's like training wheels. They're to help you understand what you're doing so that when you later are needing to ride a bike on your own, you do not fall over and hurt yourself. So that's the idea. So feel free to let me know if you have any questions, and I love interacting with people. If you have any questions, you want to talk to me, if you want to ask about this or any kind of math topic, feel free to leave me a comment or send me an email or whatever works for you. Have a nice day.